going to lecture a bit on section 3.3. 3.3 is, in some sense, a nice section because most of the problems can be done without any algebra, which makes them go quickly. The main issue with 3.3 that might slow you down is that, in terms of a test, is when a problem doesn't have much algebra. If any algebra, it's almost impossible to give partial credit. So I'm going to answer these the best I can, and hopefully I do a good enough job so that when you see these on the test, they don't stump you. So the first few questions give me pictures and ask me to find different features in terms of the graph. So in section 3.3, number 2, the first thing it's asked me to find are X-Intercepts. And there's no algebra to do because there's not a function or an equation. There's just a picture. The X-Intercepts are the points on this graph where it crosses or touches the x-axis. So they're going to be the points, I'll say, on the x-axis. And I'm going to write for the X-Intercepts -1, 0, and 5, 0 because the x-axis is the horizontal axis. And the points of the graph that are on that x-axis are the 2 points, -1, 0, and 5, 0. So that's all there was to do for 1A. 1B will be similarly easy. 1B, it asks to find the y-intercept, and that's just going to be a point. I forgot to write x for the last one. For the y-intercept, it's just going to be the points, or the point on the y-axis. And I'll write it as a point. I'm assuming, because this has a 0 there, that 0, -5 is the point that's physically on the y-axis. So I'm going to write for the y-intercept answer 0, -5. Those are the easy ones. The intercepts are always points on the axes. The next few are a little bit harder. We do them in intermediate algebra, and you may or may not remember. If you remember those, that's fantastic. If not, that's not alarming. It's probably more common to forget these than not. Part C that says for what values of x is g of x equal to 7. What C is, so A is asking me for the points on the x-axis, B is asking me for the points on the y-axis. C, this is asking me for the x-coordinate of any point that has a y of 7. The number to the right of the equal sign stands for a y that corresponds to the x. So number C is really, it's given me a y equal to 7. Find any point, the x-coordinate of any point that has 7 as its y. And there's only going to be one answer to this. I'm going to write x equals, because I'm finding the x-coordinate. The point that part C calls out as the point 6, 7. That's the only 7 I see anywhere. It's in the right position. It's in the y. So for part C, I'm going to say, well, for what values of x is y equal to 7? That would be 6, because g of x is interchangeable with y. And then part D, to find g of 0, that's given x equal to 0. Find any point find the y value of any point that has x equal to 0. So I'll look at the graph, I'll look at all the points, I'll try to find any point that has a 0 comma some number. The y next to that 0 is what I need. So for part D of this particular problem, this is the only point that's going to be necessary. For what it's worth, this was the point that's necessary for part C. So g of 0 is going to be -5. There's multiple ways I could answer this. I can write g of 0 equals -5. That would be correct. If you want to, you can say y equal to -5. I probably wouldn't write the point 0, -5. I'd probably write one of those two for the answer. The last two questions aren't new. The last two questions, the domain and the range, I read from left to right or bottom to top. I'm assuming that this graph doesn't need to be extended because the endpoints are labeled. And for that matter, I should have dots for all these points that I don't really have. Maybe I'll go and put those back in. So the domain, it's going to be all closed brackets because the endpoints are stopped. Since there's a marking at the end, the left end and the right end, I don't need to extend the graph. For the domain, the first thing I'm going to write is the x-coordinate of the far left point. And then I'm going to write comma, and then the x-coordinate of the far right point. Square brackets because I'm not getting any infinities. And in terms of this problem, the far left point is the point -1, 0. Its x is 6, so I'm going to write -1 first in my square bracket. And the far right point is the point 6, 7. I'm going to put a 6 after the -1 because that's the x-coordinate of the far right point. And for the range in this particular problem, because it's a graph that's connected, I'm going to take the y-coordinate of the bottom point, and then a comma, a y-coordinate of the top point, all square brackets because I'm not having an infinity so I don't have to extend the graph. For this particular range, the bottom point is the point 2, -9. The y-coordinate of the bottom point is -9. The top point is the point 6, 7, and the y-coordinate of the top point is 7. So that would be every answer for number 2. And you notice there's no algebra to do because the function is written as a graph and not given as an equation. There'd be no algebra at all I could do to get this answer. So hopefully you could do 1 and 3 with this inspiration. If not, I'll do problem 4, and hopefully that inspires you to answer 1 and 3. So the questions are essentially the same. Question A asks me to find the x-intercepts. X-intercepts are points on the x-axis, so it's going to be -1, 0 and 5, 0, because those are the points on the x-axis. The y-intercept is the point on the y-axis, so for A, I needed the points -1, 0, and 5, 0. For B, I need the point 0, 5. C is asking me to find the x value for any point that has 9 as its y. So C is calling out the point 2, 9. It's asking me to find the x that corresponds to 9. The 9, because it's to the right of the equal sign, stands for a y. The answer to part C is going to be x equal to 2. D is asking me to find the y-coordinate of any point that has x equal to 5. D is calling out this point because that's the only point that has an x equal to 5. And I could write, for an answer to part D, f of 5 equal to 0, or I can write y equal to 0. It's asking for the y-coordinate next to the point that has the 5 and the x. So these two are the new ones. We did A, B, E, and F in earlier sections. So if you notice the questions C and D of each of the parts, questions C and D for numbers 1, 2, 3, and 4 are all kind of worded the same way. In question C, it tells me it's asking for an x, and it doesn't seem obvious that it's giving me a y, but it is. So each of the part C's, as well as probably problems 1 and 3, part C, the number that's given is the y. You search the graph to find a point that has that as its y-coordinate, and it's asking for the corresponding x. For each of the 1, 2, 3, and 4, the D, the number because it's given because it's in a parenthesis, stands for the x, and I want the corresponding y. This problem, the graph doesn't have periods at the edges, so it needs to be extended. I'm assuming in question 2 the graph didn't need to be extended. And when I look at this graph, it's supposed to be extended down and to the left and down and to the right. The down and to the left extension is a negative infinity because left is negative, down is negative. The extension to the right is a positive infinity, negative infinity, because right is positive and down is negative. And this point up here is the only other point that I'm going to need marked, in order to answer the domain and range questions. So there's lots of points on the graph. Because the graph is connected, I need to write my domain in interval notation and my range in interval notation. And because the points at the edges of the graph, the bottom edges, weren't labeled, I needed to extend the graph to the infinities. Anytime I get an infinity in my domain or my range, I'm going to put a round bracket. So for this problem, the extended version of this problem, the domain is going to go from the x coordinate of the far left point, which I had to make up, to the x coordinate of the far right point. This is going to be negative to positive infinity. Hopefully that feels like review because we did that just recently. If it doesn't, you need to go back to the last section and get that down. The range, I need the y coordinate of the bottom point and the y coordinate of the top point. There's kind of two bottoms. It's not the case that one side is lower than the other. They both have the same y. So the first number I'm going to write in my range is negative infinity, the y coordinate of the bottom point. And then I'm going to pick out the top point, and its y coordinate is 9. Infinities get round brackets, so I'm going to go round bracket negative infinity, comma 9, because I'm going y coordinate bottom to y coordinate top as I do my range. So I'm going to go negative infinity, comma 9. The 9, because it's physically on the graph, should get a square bracket. The infinities, because they aren't points on the graph, they're just where the graph heads to, should get round brackets. So hopefully you can pause the video, do 1, 2, 3, and 4. Should check your answer, their answers to every single odd problem on my website, so you can print them out or open them up and look at them so you can check yourself. The next problems, again, don't have any algebra. There aren't any names written. And the next problems, for whatever reason, many students just, it baffles them. And I'm not sure how to unbaffle you, but hopefully by doing enough problems, it unbaffles you a little bit. So this function, this graph is called I'm calling this equation f of x. It's some parabola. And there are two questions. The first question that's asked for this particular picture is find the values of x where f of x is greater than or equal to 0. And this is asking me for the x coordinates of the interval where the graph is above or the x-axis or touching the x-axis. So I'm going to draw a big line through the x-axis so you can see the x-axis. This is the x-axis right here. This is considered above the x-axis. This is considered below the x-axis. I'm trying, and let me just, these points that I labeled are important points. Notice I didn't even label the vertex here because it wasn't an important point. So if I look at this graph and I want to find the x coordinates of where the graph is above the x-axis, or maybe above or touching the x-axis, the portion of the graph that I'm concerned about is this portion from here to here. That's the portion, if I look at this graph, this portion is where the graph is physically above the x-axis. And that's between x equal negative 6 and x equal to 2. For part A, the answer I'm going to write, I'm going to say the function is greater above the x-axis, or the y values are positive between negative 6 and 0. There's no algebra to do, it's just understanding. This is asking what region of the graph are the y's positive, or equivalently what region is above the x-axis in terms of x. Part B asks the question, where is f of x less than or equal to 0? In part B, is asking for the x coordinates of where the graph is beneath the y-axis or the x-axis. So this part right here, this is asking for the x coordinates of where the graph is beneath the x-axis. So the graph is either above or beneath the x-axis. Now I'm looking for where it's beneath the x-axis. The graphs here need to be extended. This is going to extend to the negative infinity because there aren't any periods at the end. This is going to extend to the positive negative infinity. So if I look at the graph, it's either above or below the x-axis. If I looked at this graph closely and understood the difference between above and below, this region of the graph and this region of the graph are the regions that are below the x-axis. So somehow I want to write the x coordinates of the regions where the graph is below the x-axis. In this region, that's between negative infinity for the x and negative 6 for the x. The graph is below the x-axis. I put a round bracket on infinities always. Because of the or equal to, I put a square bracket on the negative 6. And so this is the one region where the graph is below the x-axis. It's disjoint from the second region, so I have to write the second region as its own interval. The second region where the graph is below the x-axis is between 2 and infinity in terms of the x. Notice as I wrote my 4 points on this graph, I didn't show any y's because this question only asks for the x coordinates where the graph is below the x-axis. So the answer to part B of number 6, the graph is below the x-axis for any x value between negative infinity and negative 6, and then again any x value of x between 2 and infinity. I put square brackets for all the non-infinity numbers. This should be 2 right here because it's between 6 and 2. And if I wrote that, I messed up. So when I wrote the answer to where it's above the x-axis, I'm only supposed to write x coordinates. And on the picture I wrote it's above the x-axis between the point negative 6, 0 and 2, 0. When I wrote my answer to part A, I should have wrote negative 6, 2, because that's the x coordinates of where the graph is above the x-axis. I don't want to get y coordinates in there, and I snuck a y coordinate in there, and that was flat out wrong. So this is the answer to problem 6. There was no algebra to do. I needed to be able to look at the graph and the axes and decide what region of the graph is below the x-axis, what region of the graph is above the x-axis, and write each region in an interval. I'll attack number 8 and maybe do it a little bit differently, and maybe that little bit differently is going to help you. The graph needs to be extended in number 8 because it has no periods at the end. This point right here, I'm going to write negative 6, comma. I don't want to influence myself with the 0 because I don't need it, so I'm not going to write the 0. This point right there, I'm going to write 4, comma. And then I'm going to extend the graph up and to the left. It goes to negative infinity, comma, positive infinity. I'm not going to write the positive infinity. And off to the right, it goes to positive infinity, positive infinity. Now I'm going to break the graph down into its segments. The first bit of this graph, this portion of the graph, it goes between the end of the graph and an x-intercept. As an interval, this is the region from negative infinity to negative 6. I'm going to put a square bracket on the negative 6. For that region is either going to go as a part of the answer for A or part of the answer for B. That region, negative infinity to negative 6, which is between the edge of the graph and an x-intercept, it goes in A if it's above the x-axis. It goes in B if this region's beneath the x-axis. Because this region is clearly above the x-axis, this interval between negative infinity and negative 6 is part of the answer to the question for what values of x is f of x greater than or equal to 0. Now I'm going to look between this x-intercept and that x-intercept. I'm going to create an interval that's described by this in terms of x's. And in terms of x's, this is the interval from x equal to negative 6 to x equals 4. That region needs to be put in my answer. To figure out if it goes for part A or part B, I ask myself, is that region above or below the x-axis? Because this region is below the x-axis, the interval from negative 6 to positive 4 is part of the, whereas the graph below the x-axis, or whereas f of x less than or equal to 0. I hit an x-intercept, I start a new interval. My last interval is going to go from the x-intercept of 4, 0, to the final edge of the graph, and I'm going to create another interval, and that interval is from 4 to infinity. So there's 3 intervals that need to go in my answer. Any interval that's beneath the axis goes in part B. Any interval that's above the x-axis goes in part A, because A is greater than 0, y is above the x-axis. And this, because this region is above the x-axis, I'm going to put it in the A region. Since there's 2 intervals, I separate them with a union sign. So there isn't anything to do but break the graph up into where it's above and below the x-axis. To do that, you need to find the x-axis, mark the x-intercepts, and then break the graph into segments that separate the left edge, the right edge, and the x-intercepts. 8's a little more complicated. 8's going to have extra regions because there's 3 x-intercepts. I'm going to pick up an extra region. For 8, the left extension of this graph goes to the point negative infinity, comma, negative infinity. I'm not going to write the y. The first point I come across is the point negative 6, comma 0. That's the first region I'm going to look at. It's the region from the left edge of the graph to the first x-intercept. That region, I read from left to right. It starts at the left x, ends at the right x. This region, negative infinity to negative 6, is one of the regions that needs to go in my answer. And I have to decide if it goes in the region A for regions above the x-axis where they have positive y's, or B below the x-axis where I have negative y's. Because this region between negative infinity and negative 6 is below the x-axis, I'm going to put that interval in part B. I'm going to continue now on my graph until I get to another x-intercept or the end, whichever happens first. So as I march along on my graph now, I'm going to keep going, and eventually I'm going to be told to stop again, and the x coordinate of where I stop is going to be negative 1. I don't care what the y coordinate is. So that's going to create another interval. That interval is going to be negative 6, comma negative 1, all square brackets because of the or equal to's with the inequalities. That region's either above or below the x-axis. If it's above the x-axis, it goes for part A. If it's below, it goes for part B. Because it's above the x-axis, I'm going to put the interval between negative 6 and negative 1 in the top A answer. Start my graph again, and I'm going to go around till I hit another x-intercept or the end of the graph, whichever happens first. As I go around, eventually I butt up to that x-intercept. Don't need that y again. And this is going to mark out the interval from x equal negative 1 to x equal 3. Because the graph is beneath the x-axis, I'm going to put that interval in the part B because its y's will be negative. I have 2 intervals, so I separate them with a union sign. And now I'm going to continue. I'm out of x-intercepts. I'm going to go from the last x-intercept to the end of the graph. The graph needs to be extended. It extends to double positive infinity, but I don't need the y. And if I put the y down, it's just going to mess me up. So the last interval that I'm concerned with is this interval from 3 to infinity, the x-coordinate of the last x-intercept to the x-coordinate of the end of the graph. Because that portion of the graph is above the x-axis, I'll put that in part A. I have 2 intervals in part A, so my answer should be that. So my answer for part A should be the f of x is greater than or equal to 0, or the y's are positive, or the graph is above the x-axis between -6 and -1, and then again between 3 and infinity. And for part B, I have negative y's, or 0, but I'm not so worried about the 0. I have negative y's, or f of x is less than or equal to 0, or the graph is below the x-axis between -infinity and -6, and then again between -1 and 3. So there's no algebra to do. We need to break the graph up into segments, separating the end of the graph and the x-intercepts and x-intercepts with themselves, and only focus on x's. Last one of these we get to do. Problem 12, I'm going to start off. I get the left edge of the graph all the way down to an x-intercept. That x-intercept has an x-coordinate of 4. This edge of the graph is -infinity comma something. The first interval I'm going to write in my answer is the interval from -infinity to +4. Infinities always get round brackets because of the or equal to. The 4 gets a square bracket. Because that region's above the x-axis, I'm going to put that region, that should be a round bracket on the infinity, I'm going to put that region, -infinity to 4, in part A. I'm going to get back to my graph, go from the x-intercept until I get to another x-intercept, or the end of the graph if I get there first. But I'm going to get to another x-intercept before I get to the end of the graph. The next region that's marked out is the region between positive, that should be -4, and this should be -4, because that's to the left of that should definitely be negative. I just crossed out the negative so I didn't see it. So in my answer, that 4 should be negative. So this region that's blacked out here is the region between x equal -4 and x equal to 2. Because this region is beneath the x-axis, I'm going to put -4 comma 2, all square bracketed, in the bottom part B, because the y's are less than 0. The next interval that's going to be marked out is this interval. That's the interval between 2 and 6 in terms of the x. And because that's above the x-axis, I'm going to put it in the top region. I have 2 intervals in the top region, so I separate them with a union. And then I need to extend the graph. This extends to +infinity comma -infinity. And this last region is going to be from 6 to +infinity. This last region is below the x-axis, so this region from 6 to +infinity goes in part B, where the graph has negative y's, or f of x is less than 0, less or equal to 0. So I put a union symbol between because I have 2 regions. So those problems aren't supposed to be baffling. But when we integrate the next problems in these problems, this is where life starts to get difficult. So they don't have any algebra. The questions with the inequalities are asking for where the graph is above and below the x-axis. The next problems ask me to look at the graphs differently and not to break the graph at the x-axis. For each of the problems here that we just did, because of the less than or equal to 0 and the greater than or equal to 0, it's asking me to look at the graph above and below the x-axis, which is not going to be the case for the next few problems. The next few problems have one heck of a lot of items, and there's a lot going on. So let me blow up this graph a little bit. The graph to problem 14 has some big numbers on it, but that's not such a bad thing. So the graph to number 14, I'm going to draw it in colors, has the first region that goes from, I didn't write the x-intercepts on because I don't need them. It has this region right here that goes from the left edge, which is -infinity comma -infinity. I'm not going to write any y's. I'm not going to need the y's. To this point up here, which is 3 comma 41. Temporarily, I'm not going to need the y's. I'm going to look at this graph differently than the last graphs. I'm going to look at this graph in the regions where it's going up and going down. This portion of the graph, I say the graph is increasing in this interval. It's increasing between negative infinity and 3. And then at 3 it turns around. It's not going up. As I move from left to right, it's getting higher. So that's why I say it's increasing. At 3, it's turning directions. And at x equal to 3, the graph starts going from left to right. It starts going down. If I continue this graph, which goes something like this, so this portion of the graph, as I move from left to right, the graph is moving, it's getting higher as I move from left to right. This region of the graph, as I move from left to right, the graph is going lower. So for that region of the graph, I say the graph is decreasing. So for this graph, I'd say the graph is decreasing from x equal to 3. It should be negative 3. This should be negative 3. That should be negative 3 to 4. Just blowing my signs up here. But if I took that point down properly and looked at its x coordinate, that's negative 3. And again, just can't see that negative 3. At x equal to 4, the graph turns around again, and it just kind of works its way up forever. It doesn't end. It goes up forever to positive infinity, positive infinity. This last region after the graph turns, I say that in this region, the graph is increasing. So this graph, it would be proper to say it's increasing between negative infinity to negative 3 in terms of the x's. And then from x equal negative 3 to x equal 4, it's decreasing. And then from x equals 4 to x equals infinity, it's increasing. I'm putting round brackets on the negative 3 and the positive 4 because it's not increasing or decreasing there, it's turning. And it's appropriate to put round parentheses, but if you put square brackets, it would be okay. So the first few questions in problem, which this must be 14, it asks find the intervals where the function is increasing and find the intervals where the graph function is decreasing. And I'm going to write those answers down. It's increasing between x equal negative infinity and x equal negative 3. It's also increasing between x equal 4 and x equal infinity. So for part A of this particular problem, I'm going to say it's increasing in the region between negative infinity and negative 3. And then again, it's increasing in the region between x equals 4 and x equal infinity. Part B says, where is the graph decreasing? The graph is decreasing between x equal negative 3 and x equal 4. It's in this black region that I drew. So I'm going to write the graph is decreasing between negative 3 and positive 4. So that's part A and part B. The next part, C, D, E, and F, I don't need to blow up the picture. A point that's at a high point we call a local maximum. So this point, negative 3 comma 41, I would call this point a local maximum. It's not the highest point of the graph, but it's higher than any point around it. And this point here, for negative 73.33, I call a local minimum. It's not the lowest point of the graph because there's over there the graph goes lower, but in the general vicinity, it's a low spot. So the C, D, E, and F have me look at for the peaks and the valleys of the graph. Peaks of the graphs are called local maximums. Valleys of the graph are called local minimums. And part C, find the x values where the graph has a local maximum. Well, the graph has a local maximum at that point, negative 341. So the x value of where it has a local maximum is negative 3. Part D, the y value that corresponds to that point is the maximum value. So in this region, there isn't a point that has a higher y value than y equal to 41. So the answer to part D, the local maximum value, is going to be the y coordinate of the local maximum spot. Part E says find the x values, if any, where the point has a local minimum, and that's going to be that low part there, which is going to be x equal to 4. And then it asks for the local minimum value. The local minimum value is the y-coordinate of the point where the minimum is at, and that's going to be negative 73.33. So there isn't going to be a point close to that that has a y value less than negative 73.3333. So these parts are supposed to be easier. The maximums and minimums are high and low spots, and the corresponding questions after the x's ask for the y's in a more mathematically elegant way. This is a big deal in calculus and in brief calculus. So this is just prepping you for when you get to calculus. In calculus, you won't be given a picture, you'll be given a function that you need to answer these questions about without having the graph in front of you, and it requires calculus to do that, so I can't do that for you. So I'm going to look at this graph closely, and I'm going to break it up into regions. So the graph looks like this. The first region, well, the first region is this region right here, between the edge of the graph and this local minimum. This right here is a local minimum. It's a low spot. And in this region of the graph, which is between this far x, which is negative infinity, and this x, which is negative 3, in this region, I say the graph is decreasing. So between the left edge of the graph and between the local minimum at negative 3, as I move from left to right, the graph is decreasing. So when I go to answer the increasing and decreasing sections, I read the graph from left to right. The first interval I'm going to put is the interval from negative infinity to negative 3 between the edge of the graph and the local minimum. The graph is decreasing. Then the graph is going to turn around. And it turns around to this high spot right here. The graph actually does this. This is the point 0.05, and that's a local maximum. It's higher than anything real close to it. It's a peak. In this region, the graph is increasing because as I move from the local minimum to the local maximum, as I go from left to right, the graph is going up as opposed to down. So in my increasing and decreasing answer to this question, I'm going to say that this graph is increasing in the region between the local minimum and the local maximum from negative 3 to 0. I put all round brackets on increasing and decreasing because at the place where it bends, it's not increasing or decreasing anymore. And then if I continue the graph is going to go down a little bit. This graph actually goes like this to the point 1, negative 2. I get another local minimum. This graph has two local minimums. And in this region between x equal to 0 and x equal to 1, as I move from left to right, the graph is going down. So it's decreasing in that interval. So the interval from 0 to 1, the graph is decreasing. And then the rest of the graph, it goes up like this. This region from the local minimum here to the end of the graph is increasing again. And that region right there is the region from 1 to infinity. So I broke this graph up into 4 separate regions. The first, from the left edge of the graph to the local minimum of negative 3, it's decreasing. From the local minimum to the local maximum, the local minimum at negative 3 to the local maximum at 0, it's increasing. Then again, from the local maximum at 0 to the local minimum at 1, it's decreasing. And then from the local minimum to the end of the graph, it's increasing. I'm going to take these and put them in my answer now. So in for my answer to part A, the function is increasing from negative 3 to 0, union 1 to infinity. And for part B, the graph is decreasing in the interval from negative infinity to negative 3, union 1 to infinity. And I completely just copied those from this sheet. where I broke the graph up a little bit. All right, so this graph has actually 2 local minimums and 1 local maximum. This point right here, this point, so if I magnified this graph, it goes kind of like this. This point, -3, 130 is a minimum. This point, 0.5 is a local maximum. And this point, 1, -2 is a local minimum. And find the values of x where the graph has a local maximum. It has a local maximum at that point, 0.5. The value of x is 0. Find the local maximum value. The local maximum value is the y-coordinate of that. And that's going to be y equal to 5. For part E, find the values of x where it has local minimums. It has 2 low humps. The values of x are -3 and +1. The y values are asked for in part F, and I'm going to say it's -130 when x equal to -3 and -2 when x equal to 1. So part F asks for the y-coordinates of the local minimums, and because there's 2 different local minimums, I need to tell you what each y is paired with. The -130 is paired with the -3, whereas the -2 is paired with the +1. So that's everything that needed to be answered for problem 16. '18's much nicer. It's just a nice parabola. When I look at problem 18, the end of the graph has a -infinity, comma, something. I don't care about the y. This region of the graph, between the end of the graph and this point that's a local minimum, the graph is decreasing, because as I move from left to right in this region, I'm going downhill as opposed to uphill, so the graph is decreasing in that region. That region is the region between x equal -infinity and x equal to 3. So if I want to answer the question where the graph is decreasing, it's decreasing between -infinity and +3. At +3, it turns around, it stays turned around forever to the end of the graph. In this region, between x equal +3 and x equal infinity, the graph is increasing as I move from left to right. So there's only one bend in the graph, makes the increasing and decreasing easier to answer. For C, there is no high hump. There's no, this spot right here, this point 3, -4, it's a valley. This is a local minimum. There isn't any high spot like there were in the last graph, so there is no value of x that gives me a local maximum. So for both part C and part D, I'm going to write none, because there aren't any peaks. There's just a valley, and a valley is a local minimum. Part E, find the values of x where the function has a local minimum. It's going to be x equal to 3. That's the x-coordinate of the vertex of this parabola. And the local minimum values is going to be the y-coordinate of that vertex, which is -4. So there's no algebra. I don't think I've done any algebra in this section whatsoever, and that's almost every problem in this section until we get to the very end that has any algebra. 20 and 22 ask the same questions. 20, again, it doesn't have as many bends to it, which should make it easier. The graph needs to be extended down and to the left, and in the first region of the graph, as I move from left to right, the graph is increasing because it's going uphill as I move from left to right. It has positive slope in some sense. I'm going to say the graph is increasing between -infinity and -2. I'm only writing x coordinates for the increasing and decreasing. And then it turns around, and from the hump to the end of the graph, it's decreasing. So this region, we say the graph is decreasing. And that's the region from x equal to -2 to x equals infinity. Generally, and all the increasing and decreasing, we only use round parentheses because at the peak or the valley or the maximum or the minimum, it's neither increasing nor decreasing, it's changing directions. For part C, this point, -2, +3, is a local maximum. It's a high spot. So the values of x where the function has a local maximum is going to be x equal to -2. The local maximum value is the y-coordinate of the maximum, which is y equal to 3. And for parts E and F, there isn't a local minimum. There isn't like a low hump. So I'm going to say there's none and none for parts E and F because there aren't any little low spots like there were in the last problem. I believe 22 is the last one of these problems. And in some sense, it's tricky. The graph doesn't have any points labeled, nor does it have any bends. I'm going to label the x-coordinate of the far right edge and the x-coordinate of the extended far left edge. And this entire graph, it never goes downhill. To draw the entire graph as I move from left to right, it's increasing the whole way, and it's never decreasing. This graph is increasing. It's going uphill or has positive slope all the way between negative and positive infinity, and it never turns around and goes downhill. So the intervals where the graph is decreasing are none. This graph doesn't have any local maximums or local minimums. It doesn't have any high or low spots. So all of these are going to be nones. And that's all there is to do for 22, because there aren't any peaks or valleys. It's only going one direction. It never changes from increasing to decreasing or decreasing to increasing. You need a change in direction to get a maximum or minimum value. This is a big deal. The increasing and decreasing and whether you get a maximum or minimum spot is a huge deal that you spend a ton of time in Math 212 and Math 220. This is just to get you ready so that when you hear those words in college algebra, that's not the first time that you've heard the words. So that when you've got to kick calculus and algebra into the problems, at least you kind of understand the concepts so that you're not worried about the concepts as much as the algebra. For the last problems, I can do all of the problems without understanding what I'm doing. Well, there's word problems. For the next two problems, I can do the problems without doing any graphs, and I'll do that for part A. And then for part B, I'll show you pictorially what's going on. So what problems 24 and 26 are asking me to do is find the average rate of change. The average rate of change is the slope of the line that connects 2 points. Oh, I'm going to draw this. Very specifically, let me draw this function on my calculator, then I'll copy a graph. So y equals x minus 2 quantity squared minus 4 zoom standard. So this is a graph that looks something like 1, 2, 1, 2, 3, 4. Close to 0, it looks like. It looks something like this. This is not the best depiction of the graph, but it's suitable. What this is asking me to do, it's asking me to find 2 points on this graph. It's asking me to find the point 1 comma something and 2 comma something. I'm going to find the y-coordinates by, I'll cheat. I'll find the y-coordinates on my calculator by going second in table. I arrow until I see some y's. And I see the point 1, -3 is a point on this graph, and the point 2, -4 is a point on this graph. I'll show you how to get those y's if you don't have a graphing calculator. So this graph goes through the points 1, -3 and 2, God, that's horrible. Goes through the point 1, -3 and 2, -4. What the average rate of change is the slope of the line that connects those 2 points. It's going to be some negative number. So what I'm asked to do is find 2 points on the graph. I'm given the x coordinates. I need to find the y coordinates. And I want to find the slope of the line that connects those 2 points. I'm just going to use the slope formula. So once I get the points that are implied, then I can use the slope formula to find the average rate of change. Just in case you didn't know how to get these y's without your calculator, to get this y, I plug 1 in for x. I'm going to go 1 minus 2 squared minus 4, which is going to be negative 1 squared minus 4, which is 1 minus 4, which is negative 3. To get that y of negative 4, I'm going to go 2 minus 2 squared minus 4, plugging a 2 in for that x. That's going to give me 0 squared minus 4, which is 0 minus 4, which is negative 4. So what the average rate of change is, it's the slope of the line that connects 2 points on the graph. Each of the parts of number 24 gives me the x coordinates of points. I need to get the y coordinates either by sneaking them from the table function on my calculator or plugging the x coordinates into the original function. And the average rate of change is just going to be the slope of the line that connects those 2 points. I'm just going to use the slope formula. I'm going to go y2, which is negative 4, minus y1, which is negative 3, over x2, which is 2, minus x1, which is 1. Just using the slope formula now, which again I'll write down just in case you forgot. y2 minus y1 over x2 minus x1. So average rate of change is just the slope of a line, but it's a very special line. It's a line that connects 2 points on a curved graph, essentially. If I do the algebra in the numerator, I have a double negative, which I can turn positive. So this is going to give me negative 1 over 1, which is negative 1. The answer to 24a, the average rate of change between 1 to 2, or the slope of that line, is negative 1. So there's a pictorial representation to what I'm doing here, but I don't need the picture to answer the question. If I wanted to do part B, I'm trying to construct 2 points. I'm trying to construct the point 3 comma something and 5 comma something, and I want to find the slope of the line that connects those 2 points, because the average rate of change is the slope of a line that connects 2 points on a graph. To find each of the y's, I'm just going to plug the numbers into the original function. So to get the y for 3, I'm going to go 3 minus 2 squared minus 4. That's going to be 1 squared minus 4. That's 1 minus 4, which is negative 3. Could have went to my calculator here, and I see the point 1 comma negative 3. Similarly, when I plug in 5, I'm going to get 5, because my calculator tells me that's going to happen. So there's the point 5. Here's the point 1 negative 3. To get the 5 by hand, I'd go 5 minus 2 squared minus 4, plugging a 5 into that. This is going to give me 3 squared minus 4, which is 9 minus 4, which is 5. So to find the average rate of change, given the x coordinates, I need to find the corresponding y coordinates. And now I use the formula for slope. So the average rate of change between the points 3, negative 3, and 5, 5 is going to be y2, which is 5, minus y1, which is negative 3, over x2, which is 5, minus x1, which is 3. The double negative in the numerator makes it 5 plus 3, which is 8. I get 8 over 2, and the average rate of change is going to be 4. So the answer to part B, the average rate of change, is just 4. I'll do 26 without graphing. All I'm going to do is for each of the numbers, I'll consider those an x, I'll find a y, I'll get 2 points, I'll find the slope of the line between the 2 points. So 26 gives me 2 parts, a part A and a part B. I need to come up with 2 points. The points are going to be negative 3 comma something and negative 2 comma something. Need to get the y's for each. For negative 3, I'm going to go negative 3 cubed minus 2 times negative 3 plus 1. If I'm feeling lazy, I can use my calculator to do this. I don't care if you use your calculator to do this. To do this, I'd go parentheses, negative 3, up arrow, 3 minus 2 parentheses negative 3 plus 1. So that's saving me brain power. The y that comes out there is negative 20. To get the next y, I'm going to go negative 2 cubed minus 2 times negative 2 plus 1. That's just plugging in the numbers into that formula for x. So I'll go negative 2 cubed minus 2 times negative 2 plus 1, and I get negative 3. So now I have my points, and the average rate of change is the slope of the line that connects those points. So the average rate of change equals y2, which is negative 3, minus y1, which is negative 20, over x2, which is negative 2, minus x1, which is negative 3. The double negative goes positive, so this becomes negative 3 plus 20 over negative 2 plus 3. That's going to give me 17 over 1, which is 17. So for part A, I'm going to say the average rate of change, I'll use a triangle for change, is 17. That triangle means change. Do the same thing for part B. I don't need a graph to find the average rate of change. I just need points. First, I'm going to plug negative 1 in for the x's. I'm going to go negative 1 cubed minus 2 times negative 1 plus 1. If I don't want to do it by hand, I can use my calculator and go negative 1 cubed minus 2 times negative 1 plus 1. So I could be mindless here. And that gives me, I did that right, a 2 for my y. The next one, I'll go 1 cubed minus 2 times 1 plus 1. Again, if I don't want to use my brain, 1 cubed minus 2 times 1 plus 1, and I get 0. So those are my 2 points. I'm going to find the slope of the line between those 2 points and call it my average rate of change. So my average rate of change, I'm going to go y2, which is 0, minus y1, which is 2, over x2, which is 1, minus x2, which is negative 1. The numerator, 0 minus 2, is negative 2. The double negative in the bottom goes to positive, so I'm going to get negative 2 over 2, which is going to be negative 1. So I'm going to write the average rate of change is negative 1. And I could do that graphically, but I don't need the graph to answer the question. So for each of 24 and 26, they're the only problems in this entire section that required algebra, and it's understanding average rate of change is the slope of a line connecting 2 points on the graph. It's understanding that I'm giving you the x's, asking you to find the y's to complete your points. The next 2 problems are word problems, and they are word problems that I took out of our brief calculus book. So when you get to brief calculus, there's a reasonable chance that you get this exact same problem given to you. Unfortunately, when you get to brief calculus, you're going to have to do calculus to get the answer. What I did to make the problem college algebra friendly is I produced this graph with the maximum point on it, which somehow is going to be important in the answer. In brief calculus, what you'll be given is everything that's with words and not the picture. And you'll be asked to solve the problem with calculus. And to solve this problem with calculus, oh, it's rather unpleasant. It might take a page or 2 and it'd be kind of messy. But the concept is going to be important. If you can have the concepts, some of the calculus concepts walking into calculus, then the concepts won't be so new to you, and you can focus on the algebra and the calculus that's messy. If you're trying to learn concepts and calculus together, it makes it harder. So this whole increasing and decreasing business, the f of x plus h minus f of x over h that we did in the last section, and these problems here, as well as the entire section 3.6, are all, we're doing calculus light. We're giving you calculus problems but not solving them except using graphs. Section 3.6, when we get to it, every single problem in that section I took from the brief calculus books as well. And again, we're going to solve the problems without calculus. When you get to calculus, just solve them with calculus. So this is a moderately interesting problem, typical of what you'll see in calculus, a really unpleasant word problem. So I need to work through the problem and try to understand what the function is, even though I don't really need to know how to graph that or completely understand the function itself. But the words here say the number of people in hundreds infected T days after an epidemic begins is approximated by this nasty function. And it says this graph models the first 40 days of an epidemic. So from the day zero, like the first day or the second the epidemic started when nobody has it, to 40 days into the future where so many people have it, this shows. And with this graph is the graph of that function. Every point tells me during a specific day how many people were infected, and it says in hundreds, so I need to multiply the numbers by 100. So the y coordinates. So this point 9 comma 3.68, if I multiply 3.68 by 100, I move the decimal over twice and get 368. This says at day 9, 368 people are infected with whatever disease is going on. This point right here, 40 comma 2.5, if I multiply 2.5 by 100, which is multiplying the y coordinate by 100, this says at day 40, 250 people are infected. And this point here says at day 0, before the epidemic started, nobody had it. But on day 1, somebody got it, and then we go through this cycle of the people getting the disease, and the number of people getting the disease goes up, and then less and less people have it. So if I want to interpret this graph, this region right here, this is the region where the number of people that have the disease is going up. It went from 0 people to 368 people at its high, and this is a local maximum that doesn't scream local maximum. But after the 9th day, the number of people with the disease starts going down, and this stops at 40 days. Eventually, the disease is going to go away, or it's going to, according to this function or this portion of the function, as time goes on, less and less people are going to be infected with this particular, whatever the disease from the epidemic is. So this graph, I have to understand the graph well. Every point on the graph, the x-coordinate represents the number of days since the epidemic began. The y-coordinate is the number of people infected. Because it says somewhere in here, in hundreds, I had to multiply the number by 100 to make it useful. So at day 9, 368 people were infected. Day 40, 250 people were infected, and so forth. So if I want to interpret the intervals where the graph is increasing and decreasing, the graph is increasing from 0 to 9. And this is when the number of people getting the disease is going, the number of people with the epidemic is increasing. There's more people, there's more people that had the disease on the 8th day than there was on the 7th day. So the number of people infected is increasing, or it's growing. More and more people are still getting it. And then this graph from here on, between x equal 9 and x equal 40, it's decreasing from the 9th day to the 40th day. And the number of people infected is getting lower. From a high of 368 people to 258 people. So the number of people infected is getting smaller. Instead of growing, there's less people having the disease. The maximum for this particular graph is that right there. And the maximum number of people infected were 368, and it occurred on the 9th day. I'm virtually certain problems 28 and 30 aren't going to be the word problems I put on the test. The word problems that we get in section 3.6 are going to be the word problems on the test. But I just wanted you to watch these and be exposed to these, just so that when you get to calculus and you get this problem without the graph, that you understand what the graph represents and could maybe scratch together an answer without calculus. So 30 is another, I don't know how interesting it is, but it says the percent of concentration of a drug in a bloodstream X hours after the drug administered is given by the function. The graph for the first 10 hours is drawn below. So what this does is, this is 0 zeros before you took the drug, and every point shows the drug concentration, and the X is the number of hours after the drug's in your system, the Y is the concentration in whatever units, I don't know what the 0.22 means. But this 0.3 comma 0.22, the 3 stands for 3 hours after you took the drug. And the 0.222 is the concentration, for those of you that are, some sort of nursing majors. I don't know if that's like parts per million or how that's actually measured, but that's the 0.222 is how much of that drug is in your bloodstream. And then this 0.10, the 10 stands for 10 hours after you took the drug. And the 0.1222 stands for the concentration. So it's going down. You have less of that drug in your blood at 10 hours than you did 3 hours. If I want to find the intervals where the graph is increasing, this is supposed to be the interval. From here to here, it's supposed to be increasing. So for part A, it's supposed to be increasing in concentration between 0 and 3 hours. So that means that the concentration in your blood is going up. So the concentration, you have more drug in your system. Concentration is going up. And then at 3 hours, that's the most of that drug that's going to be in your body, and then it's going to start, it's wearing off. And from between 3 and 10, where the graph is decreasing, for those 10 hours, there's still some in your blood after the 10 hours. I just stopped the graph there. Between 3 and 10 hours, the drug concentration is going down. So you have the maximum concentration at 3 hours, unless you take more of the pill, or whatever it is. And then what was the maximum concentration? The max concentration was this 0.222, whatever that number represents, because it's at the maximum point, the local maximum. The maximum concentration is 0.222, and it occurred, I don't know if that has 2 hours or not, at 3 hours after you took the drug. And I don't think I'm going to put those on the test. If they don't make it onto the review, then you know they won't be on the test. I haven't looked at the review today, but I don't think they're on the review. So those word problems are important to prep yourself for, but not so much for this test. Okay, so come visit me, send me an email, visit a tutor if you're starting to feel a little bit underwater, because definitely you don't want to get behind early in the semester. We've got a lot of chapters to do, and you want to get big grades on the early tests, just in case there's something at the end that's hard for you, or if your other classes get so busy and you won't be able to put the time in this class that you need to. You want to definitely try to get lots of A's and B's on the early tests. Not that the class gets harder as we go on, but just life gets harder because your other classes start to really dump on you. So please come visit me and let me help you with this, because it shouldn't be horrible. If you didn't get it from my videos, if you just sit down with me for a while with your questions, I should definitely be able to make you understand this. This is not beyond anybody. So if you're feeling a little overwhelmed, it's completely okay. Sometimes just hearing it said a little bit differently might make all the difference.